Yeah, so today we are discussing about the double integration. The topic name is today we are going to discuss double integration. So before that, let me explain what is the double integration and what is the integrations part. Okay, I will share the one blackboard. Just, see here. So first of all, what is the integration? So we know that what is the meaning of the integration. So integration is nothing to that is anti-derivative. So what is the meaning of integration? So integration is nothing to what is that? That is anti-derivative. Okay. So what is the meaning of derivative? So that is also important, no? So what is the meaning of derivative? So what is the meaning of derivative means the rate of change of variable with respect to another variable. So that is called that derivation or differentiation. So in the intermediate level, we have that derivation and we have integration part is also. But in the UG first year, we have that integration completely in the differential equation, we have the integration part will be there. So now we are solve that double integral. Okay. So when we are using to the double integration, so double integration means, see, let me explain. So this is the x-axis and this is the y-axis. And here the one surface is there. This is okay. Now we need to find this area of this all these things. Okay. So this surface we are dividing into n sub parts, n sub equal parts. Okay. Now let's say this is the one rectangle is there. No. So what is the area of the rectangle that we know that L into B. Okay. The length into breadth. So what is the L means? So this is a L. So this is what is that? These are the points are what is that? X1, X2, and X3, and X4. Okay, na? So this is the length. So the length is what is that? X3 minus X4. So X3 minus X4 is means that small changes in the X values. The small changes in the X values that we can write what is that? Dx. Okay, now? So therefore the L equal to is become what is that? Dx. Next, B. But this is no. So this part. Okay. So this is Y1. So this is Y2. And this is Y3. So the difference between Y3 minus Y2. The small difference between the two Y values that we can write what is that? Dy. So dx into dy. Okay, no? So this is dx into dy. So the completely that we can write just this is the only the area of the small part of the region. So if you need to find the all the parts of region, so we need to summation. So summation of first I am writing I equal to 1 to n, and next the summation of j equal to 1 to n, and that is f of x comma y, where we are finding the dx dy. Okay, so we know that the summation is nothing to what is that? Integration. So integration is we have the one more definition, summation. Generally, integration is antiderivative, is nothing to what is that? Summation. Derivation means we have to dividing in the parts. So integration means so we are adding the parts. So that summation is nothing to integration, no? So that's why we are writing to the symbol of integration. And here also this one is also that we can write the integration. So that is f of x comma y dx dy. Dx dy. Okay. Okay, so dx dy. So this is the double integration part. Now let's see. Okay, so this is a just now we told my discussion about that, no? So this is the part. Now let's see here the first problem is here. So evaluate 0 to 2 and 0 to x, y, dy, dx. Here one thing you have to learn here that important. We know that what are the x limits, and the y limits. What are the x limits and what are the y limits? Okay. See, here they mention what is that first dy dx, no? So this is the first part become x limits. Now, y limits. Why? Because here initially they are starting with what is that dy. Otherwise, one more I'm telling that if the x limits either constant, either in the terms of variables of y. So y limits either constant or in the terms of the x. So let us see here, observe here one thing. See, this is here the limits are what is that first one limit is the 0 to 2. Okay. And the next limits are 0 to x. Okay. So we don't know what are the x limits and what are the y limits. But here already they mentioned that is dy dx. So the first part is become we have to do integration with y. Okay. Otherwise, we can see here this is 0 and x. So just now I told that the x limits either constant or in the variables of y. What about the y limits? Either constant or in the variables of x. So here the limits are in the variables of x, no? So automatically these are become what is that? Y limits. Okay. And next, so these are the automatically this become to the x limits. Okay. Now first we are doing the integration with uh, y. So y dy. So y dy is means what is that? Y squared by 2 and the limits are what is that 0 to x dx. So that is become y dy means the integration of y dy is y squared by 2. That is apply the limit 0 to x, that is x squared by 2. So again x square into dx, that we can write x cube by 3 and apply the limit 0 to 2 and 8 by 6. So 8 by 6 equal to 4 by 3. Okay, understood? Now this is the part. Now here is there. Sorry. Now here is there one more problem. See, evaluate 223, 224, x square y cube dx dy. Okay. So first, what are the x limits? What are the y limits? So first of all, they are giving that what is that? So we have to do dx or dy. So these are limits are in constants now. So we can take that any one either x limits or y limits. So we are taking that x limits are this is 2 to 3 and here the y limits are 2 to 4. So x square is here and y cube dy. So y cube dy is y power of 4 by 4 and what are the y limits 2 to 4. So apply that 2 to 4. So that is become 4 power of 4 minus 2 power of 4 and integration of 2 to 3 x square into dx. So now this is x square into dx, that is x cube by 3 and 2 to 3. So after the simplification and we are getting what is it? 380. Okay. So this is that evaluation of double integration. So this is very important for the short answers. Okay. In the examination, we can expected these two problems and it's very easy. Before that, you have to learn the formulas of integration. So if you know the formulas of the integration, then easily you can get it from there. See here, the next problem, that before they are giving that limits and they are asking to find the evaluated. Okay. Now they are asking to evaluate y dx dy over the region R. So what is the region R is bounded by y-axis. So y-axis is nothing to what is it? X equal to 0. Okay. And the curve y equal to x square and the line x plus y equal to 2 in the first coordinate. Okay. Na? So this is that where R is the region is bounded by x equal 0 and the curve y equal to x square and the line x plus y equal to 2 in the first chord. Now let's see here. Now this is x-axis and this is a y-axis. So this is y equal to x square, the curve. Okay. And this is x plus y, x plus y equal to 2. Okay. Now, if you are substituting here y x equal to 0, so then we are getting y equal to 2. So that's why the intersecting point is 0, comma 2 and 1, comma 1. Okay. Now let's see here. Uh, so we have x plus y equal to 2, no? So in the same way that what I put the x equal y equal to what is that x square. So when you are substituting that y equal to x square, so the equation is become what is that x square plus x plus minus 2 equal to 0. So after get we are getting x equal to minus 2 or x equal to 1. But they are giving in the question, they are given what is that this is in first coordinate. Okay. So in the first coordinate, the x values are positive. Okay. So that's why we are taking positive values. So here we get x equal to minus 2 or x equal to 1. So, but we are taking only the positive values. No, why? Because they are giving in first coordinate. So in the first coordinate, x values are y values are both are positive. So we are taking that x equal to 1 on. Okay. And next come here. Okay. This is the part. Now come here. Now the x values are that is 0 to 1 and y values are what is that? That is x plus y equal to 2. So from there we can write y equal to 2 minus x. Okay. Next y equal to x square. Okay. But here we have the two y values. So what is the lower limit and what is the upper limit? So we have to get that one confusion. What are the lower limit and what are the upper limit. So before that, we need to get the graph figure. Okay. See one thing. So when we need the y limits means, so we have to draw the line, okay, that parallel to y axis. So when you draw the line parallel to the y-axis, so this is the line. So where it is first that meeting is y equal to x square. Where that is the meeting is x plus y equal to 2. So that's why we can take y equal to x square is that lower limit and 2 minus x is the upper limit. So understood? So if you need the limits of x, we have to draw the line parallel to x axis. So where they are meeting, that is the x lower limit, and where it is exit, that is the upper limit. Okay. Now, so this is that. Now see, now y into dy dx. So y dy that is become y squared by 2. So y squared by 2 is the outside. So now we can take that y equal to x square and y equal to 2 minus x. Okay. So after the simplification, y square by 2. So in place of y, we have to substitute 2 minus x, and that is 2 minus x whole square. And in place of y, we have to substitute x square, that is become x power of 4. Now we have to do this integration. And after that, we need to substitute that values, that x limits, and we are getting 16 by 15. Okay. So this is an important task. And this is also important problem. So evaluate x plus y into dx dy over the region y equal to x square and y equal to x. So this both are very important. So y equal to x square. So this is that y equal to x square. And this is y equal to x. Okay. Now see here, y equal to x square and y equal to x. Now from these two, we are getting what is that? X square equal to x now. So that is become x square minus x equal to 0. And x take common. That is x minus 1 equal to 0. That is x equal to 0 and x equal to 1. Hmm? So this is the part. So first we have to do the integration with dy. So when you are doing the integration with the dy, so this is y is integration is y square by 2 and y square integration is y cube by 3. And the limits are what is that? Upper limit is x and lower limit is x square. So before I told you how we can find this is y equal to x square is the lower limit and y equal to x is upper limit means for the y limits we have to draw the line parallel to y axis. y limits we have need to write the parallel to okay. So now this is integration. So x equal to 0 to 1. Now in place of y, we have to substitute first x, and after that we have to substitute in place of y x square. So after substitution, and we are getting to this one. Okay, next. So after doing the integration with x and substitute the limits 0 to 1, and finally we are getting what is that 3 by 56. Okay, and this is a very important problem. Okay, and your so here are the limits are in variables. It is not in variables. It is are the constant. So easily you can do it. So you can try this problem. This one. Okay, these are the y limits and these are the x limits. So let me explain. So this is become right. What is that? X is x squared by 2. The limits are 0 to 2. And y is y squared by 2. And the limits are 0 to 3. So this is x square is 4 by 2. And this is 9 by 2. Why? Because in place of y, we have to substitute 3. That is 9 by 9. And that is 9 by 2. That is 36 by 2. That is 80. Okay. So this also you can do it. The double integration. So first we are doing with the x. So that is become x cube by 3 plus y square into x. So what are the x limits? 0 to b. And y equal to 0 to a dy. So y equal to 0 to a. So this is b cubed by 3 plus by square into dy. So that integration is become b square y plus this is by cubed by 3. 0 to a. So that is become ab cubed plus a cubed by 3. Okay, so this is the double integration formula. Okay, now this is only that order in the Cartesian form. So when it is in polar form, so double integral in the polar form. So how we can solve that? Yes. So in the polar form, so what are the polar forms? So this is a circle that is x square plus y square equal to r square. So what are the polar form is here? What are the polar equation means? X equal to r cos theta and y equal to r sin theta. These two are the polar equation for the things. So if they are in the polar equations will be there. So that in place of dx dy. So remember one thing. So in place of dx dy, that we are getting r dr d theta. In place of dx dy, that we are getting r dr d theta. Okay. So r dA equal to, that is r dr dt. Okay. For now, let's see the one problem is here. integral of 0 to pi and 0 to a sin theta or dr d theta. Okay, now this 0 to pi means this is the theta limits. So the theta equal. So this is r equal. So r dr d theta. R dr means that is r square by 2. The limits are 0 a sin theta dt. So that is a square by 2 and 0 to pi sin square t theta d theta. Sin square theta in the trigonometric level we can write 1 minus cos 2 theta by 2 into d theta. So that is a square by 4 and 1 by 2 means that is theta. Theta minus cos 2 theta is sin 2 theta by 2 and 0 to pi. So that is become pi a square by 4. Okay. So this is the topics we discussed today. So this is a double integral part. So it's compulsory for in the short answers. It's very important. Evaluate the double integration where it is in the variables in constant or where it is in the variables limits are in variables and constant. Okay.